Okay, so in this last example, we're switching up the different strategies, and I just want you to practice deciding which strategy from your strategy sheet to use and then applying the strategy. So our instructions say find x, assume that any segment that appears to be tangent is tangent. So just assume that if it's touching the circle, if it looks like it's touching the circle, it really is touching the circle. So this first one, it looks like we have a secant going all the way through the circle and a tangent. So this one I would call strategy 4A personally. And so we know that the strategy for that is that we would take the big arc in between those two lines, and then we would take the little arc in between those two intersecting lines, and we subtract the two and divide by 2, and that gives us our exterior angle, angle S, which is what we're looking for. We're looking for this red angle there. So that's angle S. So we see that we have the 45 in yellow. I don't know angle S's degrees, nor do I know the blue angle. Or blue arc for that matter. The key to this whole problem is recognizing that this line here goes through the middle of the circle, because we know if that is a diameter, if that secant goes all the way through the middle of the circle, then we know that this half of the circle is 180 degrees. So then you're going to take 180 minus the 45 in yellow to get 135 for this blue portion. So we're going to have 135 minus the 45. So that gives us 90, and then we divide that 90 by 2 to get angle S to be 45 degrees. Okay, let's look at another one. So this one, these two chords, they would be secants if we extended them out, but these two lines on the inside of the circle are crossing inside the circle. So we have an interior angle. This little point where they cross is not the center of the circle, which is why this 51 and this 74 are not the exact same amount, because they're crossing somewhere kind of in no man's land inside the circle, somewhere that's not the center. So in that scenario, we know this is strategy number 3. So if you want to go back and look at your strategy sheet, so on our strategy sheet, number 3, the interior angle, said that's the one where you take the two outside arcs and average them. You add them together and divide by 2. So that would mean that on this one, we take the arcs in between where those lines intersect, the 74 and this green one over here, and that would give us this angle here, 51, keeping in mind that that's equivalent to this angle here because of vertical angle. So it technically finds either one to be 51. All right, so our strategy, big picture, don't get lost in the fact that we don't know the green part yet, one thing at a time. Green minus blue all over 2 gives us the 51 degrees, gives us the interior angle. So we do know the blue part to be 74. We just don't know the green. So when we don't know something, let's call it x. So we have x minus 74 over 2 equals 51. Since x is in the midst of this equation, this formula over here, we're going to have to treat this whole thing like an equation and solve it for x. Since x is not already isolated, so to do that, we're going to multiply both sides of the equation times 2. So we get 102 equals x minus 74 when you cancel out those 2's on the left-hand side. And so x minus 74 equals, where did I get 75 from, Miss Benton? So we had x minus 74 equals 102. Then we just need to get x by itself, add 74 to both sides. So these cancel out, and we get x to be 176 degrees for that arc. Okay, so now you have these two U-tries down here. If you will, go to your strategy sheet. Either way, you know you're basically doing big arc minus little arc divided by 2. But go to your strategy sheet and see if you can find the strategy for these problems, and then work them out. So I will say that this first one was a strategy from the last note packet. It is not a strategy from today's lesson, but it would be good for you to go back and look at that strategy again. So pause the video, give it. Okay, I think I cut myself off a little bit, but that's okay. All right, so we're looking for our angle, a to the b to the d, which is this yellow angle here. And this is going to be strategy number 5. Okay, so strategy number 5 was this one down here, what I called the leg hanging out theorem the other day. The idea being that you have one chord or secant inside the circle and one outside the circle that make up your angle that you're looking for. So we said in that situation, then you just do half of the intercepted arc. So if we can figure out that green arc, how many degrees it is, that's all we need to figure out the yellow angle. So we know there's 360 degrees in this circle. We know 154 of those degrees are used up by the blue arc. And so if we do 360 minus 154 is 206 for the green arc, then half of that, 206 divided by 2, which is 103, that is this angle here. So how did I know to use that strategy? An important thing to look for when you're trying to determine what strategy to use is where is the vertex. So the vertex of this angle is on the rim. And remember, anytime the vertex is on the rim, that's when you just take half of the arc. Anytime it's outside, you take the two arcs, as in the second you try, you take the two arcs, subtract them, and divide by 2. Anytime you have an angle, a vertex inside, somewhere randomly inside the circle, you add them together and divide by 2. And if it's on the center, that first strategy, number 1, they're just the same amount when the vertex is on the center. So to determine which strategy to use, it's all about the location of the vertex. So let's maybe add that to our strategy sheet. This is, whoops, I got a little extra there. Okay, vertex inside somewhere. These are vertex of the angle is outside. And this one down here. Okay, so back to that last problem. So since this is strategy 4A, we're going to do 88 minus the 26 all over 2 will tell us our exterior angle H. That's an 88. And so 88 minus 26 is 62, divided by 2 is 31. And that's it.